Well, I know, but it's in there somewhere. It's easier to teach something you've learned before. All right. Secant line slash average rate of change equals slope slash line between 2 points. And then tangent line, instantaneous rate of change equals slope line at 1 point. What was instantaneous the one? Yeah. Oh, you're pretty far. Look, almost got it. Where you go? So there's two different ways to say the same thing. The secant line, the average rate of change, would be the slope or the line between 2 points. So if I give you a little sketch, I give you any 2 points, and say find the secant line or find the average rate of change, and it'd be the slope or the line, like connecting those 2 points. That's algebra, that's pre-calc, that's advanced algebra. What happens in calculus is we're like, okay, I don't want to know like the average rate of change or like I don't want to connect these 2 points. I don't want to find the average distance between them. I want to find, like, at this instant what's happening. So then we get into, like, this tangent line. So a tangent line is just at 1 point. So for a tangent line, I would give you 1 point, and your job is to, do you guys know what a tangent line is? Or no? Not really. Some yes. Yeah. Let's try something. This is going to be goofy, and I don't know if it's going to work, and if it's going to make any sense or not, but it'll be interesting. Give me like 7 or 8 people to just walk up to the front of class. We're just going to be like stand up here and do something. Now stand in like some curved pattern, like a sine or a cosine type situation. So like shoulder to shoulder, so you're kind of like weaving like a snake, let's say. I think I need more people. Shoulder to shoulder. Yeah, right next to each other. Okay, that works. Okay. So I want to explain like secant versus tangent. So if I said find the secant line between Sophie and Mitchell, and then like if you just point your arms to each other, that's a secant line. If I want to find the tangent line, let's say I want to find the tangent line at Jack. So you guys are used to slope is like between 2 points, right? So you need 2 points, like y2 minus y1, x2 minus x1. Well, I want to find the slope of Jack. Like specifically, that's only 1 point. So the way a tangent line works is you think about it a couple ways. One is like, say you're driving along this road, but it's like really slippery out. It's winter. And like right when you get to Jack, your tires lose their traction. Which way are you gonna go? You're gonna go like this way, right? That's a tangent line. If Jack were to just don't like hit people, but like put your hands up and like put your 2 arms up straight, so you're making a straight line. It needs more flexibility there. There you go. That's a tangent line. So I want the slope at specifically one spot. If I wanted the tangent slope at Mitchell, what would that distribution. Yeah, it was fun at least. So, if I wanted to find the instant rate of change, or the tangent line at this point, what's going on here, Patricia?
I'm writing down your note.
Oh, alright.
Oh,
Yeah, they're also important. So imagine this is like all these people in a row, and this is Jack, and I want to find the slope at Jack. Well, if he just puts his two arms out, that would be the tangent line at that one spot. Does that make sense what I was trying to like get across?
Yeah.
Did that work? Did that help?
It's fun.
It was fun. Yeah.
So the secant and tangent lines, do they have little arrows at the end? Like, are they continuous?
Yes. Okay. So for the secant line, you need 2 points. The tangent line, you need 1 point. Alright? So if I said, here, let's just do that. Draw something like that. Try to sketch the tangent line at each one of those 5 dots. So you got a bunch of people in a row. If this person would have just put their 2 arms out, I've never explained it that way before, but I think it kind of makes sense. Makes sense to me. That's not what matters, though. I think it makes sense to you. Let's see. I got something else I can show you next. We'll tack it a different way. We'll surf. Got this. But it doesn't matter. Just in case. People next door like it too. Yeah, but only recorded. It didn't record that. It just recorded like the voice for that. So,
Which seems more confusing.
Which probably is confusing. So if this person were to stick their arms up, it would basically be this line. I didn't really make a straight line, but how many have like something around, something like that? If this person were to stick their arms up, it would be like totally horizontal, right? So that's a horizontal tangent line. If this person were to do it, down there, if this person were to do it, this would be across. If this person were to do it, it looks like that. Yeah.
So it doesn't have to it doesn't necessarily follow the line of the curvy thingy, right?
No. All that we care about, so like, if this is Jack and he stuck his arms out, none of the other people are even really relevant anymore. They can all just go sit down and I just look at Jack's arms. Well,
but then if you turn Jack the other way, then it's this way, so that doesn't kind of follow the line.
Jack doesn't move them.
Here. But
why are you spinning around in the circle?
Well, okay, so for this one, I'm going around. Sorry. Okay, for this one, I had it here.
Oh, so but you had it like this?
Yeah, I had it like that.
That's just like I drew it slightly off, or you drew it that's just it's an estimate, right? So it's not like that's just we estimated it differently. I think I didn't draw it that well, to be honest.
Isn't tangent not supposed to cross a line? I know tangent of a circle, it's a point of a circle, and you don't cross another point.
That's because in a circle, the circle goes away from the line. So if you just isolate that one spot, it's so look at this one here. Look at this one here. This is my tangent line, and it's not touching anything immediately next to the curve.
Yeah.
But if this curve later decides it's going to turn back that way, that doesn't change the fact that that's still the tangent line at this point, even though there'd be that intersection there. The circle, that never happens, though, this doesn't, you don't have a circle that all of a sudden you're like, ooh, I'm going to go over here.
Okay.
It's because it's a circle. So the idea is true that, you only want to, at that spot, it should only touch one point, but later on, who knows?
I was more confused about the point from the one that just straight across.
Yeah, I didn't draw that well either. So, this one here.
Yeah.
All that matters is if I look at really close to it, it shouldn't touch either. But that's a really hard one to draw because you're almost, that curve and that line are almost really the same at that spot. So technically you're not really hitting any, but you're so freaking close to them that you might. And then when this curves back, you might hit it again, and this curves back, you might hit it again. And that's okay. Does that clear up what you're asking?
Mostly.
Let me try to zoom in. If we were like this, I drew, I wanted one here. It's probably going to look something like this, and it's going to hit. It's okay if it hits.
Yeah, I see it.
Alright. Let me show you a different thing. There's a surfboard demonstration online that's pretty helpful.
Really spinning the
Yeah.
Good job.
Thank you.
That's your card.
Yep.
Yes, I
It was like I'm trying to think the doctors were so I struck hands was maybe one of those last year because it was like so I had like the big ones that that's where
Okay. So, what we start to get into, first of all, you have to be able to identify a tangent line. So, let's just look at, don't worry about the bottom graph yet. This is the same exact idea as what I was trying to explain with like the people standing up. So if this were Jack standing here and he put up his arms and we followed those arms, this would be the line that was created. Or you can look at this, pretend there's a little guy surfing on that wave. The slope of his surfboard, if you just continue that in both directions, that's what a tangent line is. And you can see, so like say I'm right there. You know, that's parallel at that spot. If Jack stuck his arms out, it'd be right there. Surfboard's parallel, and we do hit the graph again over here, and that's okay. That's not an issue. It's just that this one spot we want to be parallel to the graph at that one spot. So then it gets a little steeper because this is a steeper part of the graph. Here it'd be horizontal. I don't know if I can get it like right on there, but you'd be flat right there. Now there's a negative slope. Now we're flat. Now there's a positive slope. Now we're flat. So does that help? What is a tangent line? So the next thing is we got to be able to graph a derivative. And we're not going to do that today yet, but I want to start talking. So the one on the bottom, oh, you can't even see it. Perfect. The one on the bottom is the graph of the derivative. So what the graph of the derivative, the y values on this graph down here represent the slope of the graph up here. So like at this x value, I don't know what this is. Okay, it says it's -9, whatever. At this x value, is your slope positive or negative? The slope of the surfboard is negative, right? So if we go down to the derivative graph, the y value needs to be negative. If I read across, I can tell exactly what it is. What is the slope of it? -0.97, and if I read down here, what's the y value of this graph down here? I mean, we're estimating, but it's about -0.97, right? As I go, is my slope getting less negative or more negative? Less negative. So like right here, it's approximately -0.5. My y value down here is now approximately -0.5. Right here, let's see if I can line this up perfectly. No, but close. My slope is 0.01. It's basically flat right there. So the y value down here is 0.01, or basically 0. Yeah.
So the derivative graph is just 9.
The derivative is when you connect all of them.
But like the graph isn't changing, the point isn't changing. It's changing the point up there.
It's like pre-graphed. So I'm just showing you.
So you already graphed the derivative, and that's just like how it.
Yeah, the derivative's already graphed. I wish it weren't. I wish I could like show you how it was constructed. But this is the derivative graph, and I'm showing you like where each of the points came from.
Okay. Is it the same as that graph up there or not?
No. So right here, what is true about the y value of this graph up here? Positive or negative or zero? Well, you guys are thinking way too hard.
This is negative.
It's negative. We're below the axis, right? So the y value of this is negative, but what's the value of the slope? Zero, right? So the y values and the slope are definitely different. Right here is your y value positive, negative, or zero? Approximately. Approximately zero. But is your slope positive, negative, or zero? Positive. So when I go down here, my slope, down here, these y values are slopes. Up here, these y values are y values. So we'll do more of this tomorrow. Let me just show you like another graph, I guess. So the derivative of x squared is 2x. So we'll get into that in a couple weeks. But if you just look at it as we're going, right here is my y value is up here. I'm on the top graph. Right where I am right now, where the circle is. Y value is positive or negative? Y value is positive. Slope is positive or negative? Negative. So down here, we're plotting the slope. As I go closer to the origin, does my slope get more negative or less negative? Less negative. If you notice down here, what happens to the values on this derivative graph? Are they getting more negative or less negative? Less negative or more positive, whichever way I want to say it. Right here, actually everything's zero. The y value is zero, the slope is zero, so everything's zero right there. Now my slope starts to get more and more positive, right? So the y values down here need to start to get more and more positive. Yeah, let's stop there for now. We'll do more of that tomorrow. I was just kind of introducing the graphic part. That's the kind of second level, I suppose. Let's look at that sheet that I gave you. And we're just going to do a couple problems with you. Let's look at number 1. Find the secant line. Is secant line average value or instantaneous value? Or average rate or instantaneous rate? Average. So this is the average rate of change. That means we need 1 point or 2? We need 2 for that one. So that was like when Sophie and Mitchell pointed at each other. For that moment. Key moment. So they're being nice to you on these. They're giving you both points. They won't always. They could, for example, just give you the 2x values. And then you have an equation, so they could ask you to find the 2y values. But I think on all these, they give you both. You're not really asked to find, oh no, you are. The AP test doesn't really get into average value a ton, because the entire point of calculus is we don't need 2 points anymore, we just need 1. But they do put it on there so that you understand the difference between them. So it's not like a huge emphasis, but it's on there. So find the equation of the line. This is just that y equals blank times x minus blank plus blank, like the stuff we did yesterday. I'm going to pick one of those points and plug it in to these 2 slots, like the second and third slot. That's your x value and your y value. I'm going to pick 1, 0, just because that looks friendlier to me. And so this is your x value. This is your y value. And what goes in that other slot that I left blank so far? It's the slope. And then it give me that. So I got to find it. I'm going to label these also. So -1, -2 is here. 1, 0 is here. So that's 2 points. If I connect them, it makes a secant line or an average rate of change. I need 2 points for that. For instantaneous or for tangent, I just need 1. So should my slope be positive or negative? It should be positive because that's sloping up. So let's find it. So like 0 minus -2 over 1 minus -1. It's going to be 2 over 2 or 1. And then I'd like you to put them in slope-intercept form also. I think that's probably how they give the answers. Yeah. So just distribute and combine the like terms there. So 1 times x is 1x. Minus 1, and then plus 0 doesn't do anything. So that's the answer I'd be looking for there. Questions on what I'm doing there? Yeah.
Like problems where we see, like, you just see it with the graph, so that doing all that, can we do that at the same time, or do you want to do us?
I want you to practice the process. I mean, I think that's good to be like, oh, well, I got a slope of 1 and the y-intercept of 1, and look, that matches. That's what I'm supposed to get.
Yeah.
But it's kind of just cheating. You just look at it and do it like you're skipping the part I want you to practice. You know? That's why you're such a cheat. Are those okay? Should we do another 1 or 2 of those, or are we good? Let's probably answer questions. We're good. All right. Go to like number 7. Average rate of change, is that secant or tangent? Average is secant. How many points? 1 or 2? So what they're giving you there, so over the given interval, is they're giving you 2 x values. So they're giving you -1, comma, and they're not giving you the y value that goes with it. They're giving you 0, comma, and they're not giving you the y value that goes with it. But how do we find those? We just plug in, right? So go ahead and do that one. Find the y values, then find the slope, and then plug into your point slope formula, and then get slope intercept formula. I think there's fractions here. So your secant line is like really close to your tangent line, or to the graph here. Right? We're just connecting those 2 dots. It's really almost the same as the actual graph. It's just not quite. So I don't think the hard part is going to be the calculus, it's the fractions, I guess. So I'm going to plug -1 in. That'll give me 1/2, but then there's this negative sign out here. So -1/2. If I plug 0 in, I get 1/3, but I still have the negative sign on, so -1/3. And the slope becomes a little bit of a pain because I have those fractions. -1/3 minus -1/2. So I'm doing the bottom minus the top. Over 0 minus -1. Well, that's really like -2/6 plus 3/6 over 1. If I just get a common denominator and then turn the 2 negatives into a plus, you know? You with me? So then your slope is 1/6 over 1, or your slope is just going to be 1/6. And again, pick either point you want. I'm going to choose the one with the 0 in it, just because that makes my life easier. So I'm putting 0 there, -1/3 there, and my slope is 1/6. And then distribute so that you put in slope intercept form. So 1/6 x, 1/6 times 0 is nothing, and then you got the -1/3 there. Oh, they actually just said find the average rate of change. So you could have stopped right here. I just said find the slope, basically. Yeah.
Sorry. What? Oh, could you have done it with -1 and 2? And -1 where the 0 is, and then -1/2 where the 1/3 is.
Like you did it the other way around, you mean?
Yeah, I did with the other point.
Well, there's only 2 points.
She did it with a -1, -1/2.
So, right there. How to change is the 0. To put it into some form.
Oh, you just put -1 here and a -1/2 here?
Yeah.
Oh, I was thinking like way more confusing than that.
Yeah.
Yeah, if you distribute that, you should get the same thing. You didn't?
I don't know, maybe I did. I just saw this and then it confused me, so I didn't get farther than that.
So x minus -1.
Yeah.
Minus 1/2. Okay. So 1/6 times x is 1/6x. If I distribute those, I get 1/6, right? Minus 1/2. So this would be 1/6 minus 3/6. That should be negative 2/6. That should be negative 1.
Okay.
I just think it's a lot harder because if you have the 0 there, it's just going to simplify here. But you can do. I'm sorry, I thought you were like on a whole different page, but you were just asking a question.
Yep.
Yeah, my bad. Those okay? All right, go to like number 13. So keep in mind that you're estimating here. Instantaneous rate of change. Is that tangent or secant? That's tangent. How many points? 1 or 2? And if you notice, they only give you 1 x value. So what they want you to do here, and what we're looking, I just want you to get an idea of trying to draw that like someone sticking their arms out or the surfboard. So if I go to x equals 0, put a dot on the graph, and then I'm going to try to draw that surfboard or the person sticking their arms out, or like you're driving along and your wheels lose traction, or like the Earth is floating around the sun and gravity stops existing, it'll just like float off into space. So I want you to draw that and then estimate the slope. Now keep in mind it's an estimate. Like if you draw it a little different than mine, your slope's going to be different. And they give you an answer in the back, but it's just an estimate. Basically, if it's a 45-degree angle up, what's the slope? 1. And so if you have a line that's steeper than that, you should give me a number bigger than 1. I don't really care what it is at that point. This is, what's a 45 degrees line down? Negative 1. So this looks approximately negative 1-ish to me. It may be a little bit smaller than that. I'm not really worried about like counting boxes or anything. I'm just going to go like that's approximately negative 1. I think if you put approximately negative 7, that's way too steep down. If you put approximately 0, that's wrong. If you put a positive number, that's wrong. But as long as you're close-ish, I know that's not like something that's comfortable. But I just want you to, what did they put?
Negative 1.
They put negative 1. So I just want you to be in the ballpark, though. So let's try 14. So if I go to x equals negative 2, draw my surfboard or tangent line. Is it going to be horizontal? No, but it's going to be pretty close, right? Like just a little bit below horizontal. So a little bit negative. So like if you put negative 1 here, I think you're off. It's got to be a negative number, but it should be pretty darn close to 0, right? You see why? Literally no one's not there after shaking their head.
Yes.
Thank you, okay. So I'm going to say like negative 1/5, I don't know. It's an estimate. What they put? They put negative 1/25. I don't think that's a big deal. I think negative 1/5 is fine. If you put negative 1, I would mark it wrong. Do you think that's fair? Do you guys agree with what?
Yeah.
If you put negative 1, that's too steep. Negative 1/2, I could probably even live with. I basically want to know that it's more shallow than negative 1. Someone asked something.
Oh, I said 1/4.
It's fine. I'm good with that.
Do you prefer fractions or decimals?
Fractions. Because slope is rise over run, right? Like I want to see the 2 numbers. All right, let's try 15. These are fun. No, 15 is like the same. Let's try 16. So go to x equals 1, go up to the graph, put a dot. Try to make, reach your hands out to both sides or surfboard or whatever you think about there. And here's your choices. Here, yeah, let's make it multiple choice. That'll give me an idea of if you're with me or not. Hold up your fingers. A is 1, B is 2, C is 3, D is 4, E is 5. Don't flip me out. Okay, so I think that's steeper than 1. So I think if you're saying 1, One would be this line, like a 45-degree angle. In my opinion, that's pretty clearly steeper than 1. Those either said 1. Do you see what I'm saying? You're thinking what?
When I looked at the graph, I said 1 in my head, but I'm looking at the graph again and realizing that it's 2, and that I was thinking 2 in my head. I just thought I was thinking 1.
Okay.
Basically, my thought process was really confusing on that one, and it messed me up.
Does
But I
anybody,
understand what's happening.
do you do or you don't?
I do.
Does anybody want to argue that it's 1 and not 2? Like, do you see why I'm saying 2 and not 1? Yes? Okay. So your job's to finish the worksheet. You have the rest of the class to do it. I will walk around and help, and I guess tell you if your estimates are close enough or not. That's it. I know it's tough right now because you don't know like an exact answer. Estimating is not like, how do I know if it's close enough or not? But for right now, for what we know, it's just kind of the best we can